everyone. Today we're going to do a little bit of a different video. I'm going to do some math for my kids who are 7 and almost 5. And I don't really have a plan for exactly what we're going to do. I have a rough idea and I'm going to sort of follow their questions. And you wanted to say something?
Yeah.
Go ahead.
Welcome this night.
All right. Thanks for the welcome. Take a seat. So what I wanted to talk about is multiplication. Like, what's multiplication and how does it work? And what's a way of imagining it and seeing how it works? So I wanted to start with addition, because if you start with addition, you get a sense of how multiplication might work. How many squares are here?
3.
3, right. And let's put a couple more squares here. This is 2 squares. So this is 3, and this is 2. And if I add them together, I'm writing the picture on the top and the numbers on the bottom. If I add 3 squares and 2 squares and put them together, then how many squares do I have? Anyone?
5.
5. Yeah, good job. So I can write the number 5, or I could just write all these squares together. I can write square, 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 that's those 3, and then square, square. And you see here we have 1, 2, 3, 4, 5. So this is one way of writing 5, and this is the usual way of writing 5. This is like a picture of 5, and this is the number. Right?
Yeah.
Okay. So, and this is how addition works. And if instead of adding 3 plus 2, I might add 3 plus 3. And then this wouldn't be 2, it would be 3. Right? And then when I drew the picture of 3 plus 3, I would have to have 3 and 3. And how many would that be? Not 5 anymore. You could answer 2.
6.
6. So 3 plus 3 is 6, and this is a similar picture of that, right?
Yeah.
Okay, so the useful thing about doing it with little squares is that it's easy to draw squares. So for example, I might draw something that looks like this. Now, how many squares did I draw here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Well, I got the answer by counting by 2s, but...
Okay, cool. So you could also count by 2. You could go
2,
2,
4, 6, 8, 10.
Yeah, that's another way of getting the same answer, right? So there's 10 squares here. But because of the way that it's organized, I could write this as, I could sort of split these up. I could take these 2 squares. This is kind of like your idea of counting by 2. And then I could take these 2 squares. And then I could take these 2 squares. And these 2 squares. And finally these 2 squares. And what I would get is 2 plus 2 plus 2 plus 2 plus 2. So if I asked you, what's 2 plus 2 plus 2 plus 2 plus 2, what would you say?
10.
Yeah, it's 10. Because instead of figuring it out from this, we actually started with 10 and broke it up. And we saw that 10 is the same as 2 plus 2 plus 2 plus 2 plus 2. Right? So this equals 10.
10.
And actually, we could even do it the other way. I'm going to give myself some space on this side. Here I broke it up that way, but I could break it up this way, and I could do 1, 2, 3, 4, 5. That's the top 5. And 1, 2, 3, 4, 5. That's the bottom 5.
And that also makes 10, because it's just 5 plus 5.
Right.
And that's the normal way of making 5. So you don't have to make 5 by 2 plus 2 plus 2 plus 2 plus 2.
Yeah, you mean 10, right? You don't have to make 10 by doing 2 plus 2 plus 2 plus 2 plus 2. You could also make 10 by just doing 5 plus 5. Right?
And it's easy.
And it's easy. And those are two different ways of making 10, right?
Yeah.
Yeah, and we see that those both come from the same picture, and it depends on whether we split it up like this, and then we get 5 plus 5, or whether we split it up like this, and then we get 2 plus 2 plus 2 plus 2 plus 2.
Yeah.
Does that make sense?
Yeah.
Okay, so I promised that we would talk about multiplication, and the reason that this picture is relevant for multiplication is because multiplication is about what happens if you're adding the same number to itself over and over and over again, right? This is long to write down. 2 plus 2 plus 2, and you get tired, plus 2 plus 2, right? But another way to write this that's faster is like this. 2 times, so this isn't a plus, it looks kind of like an X, and you say times 5. And the 2 is because all of these numbers are 2. And you know what the 5 is from?
No.
Do you want to say?
Well, if you have two groups of 5, then you get 10. And
That's true. That's true, but I'm thinking right here, if I look at this, if I look at 2 plus 2 plus 2 plus 2 plus 2, right, and I write that as 2 times 5, I get that the 2 comes because there's already 2 here. But why is the number 5 here? What's 5 counting?
I don't know, because there's no 5 from that one.
Yeah, there's...
But my guess is that, like, there's half of the 2.
Mm-hmm.
And then we add one of the 5s.
So maybe what you're saying is that if you take the 2's and you split them in half, then you get, like, the top one and the bottom one, and we already saw that was 5 plus 5, right?
And if you take one of those
Yeah.
and put them with 2, that could also equals 10.
Well, I think if you took one of those, which is 5, and you put it together with just 2, then what would that equal? What's 5 plus 2?
Well, can I answer?
She's counting.
Okay. It equals 7.
You're right, it equals 7. So it's not 10. And that's because in the picture, if I do 5 plus 2, here's 5 from the top, and here's 2 from the bottom, and we can see it's not 10 yet. We're missing 3 to be 10. Right?
Yeah.
So if we go back to down here to this question though, you're totally right. If I write this as 2 times 5, you might say, I understand where 2 comes from, but where does 5 come from? And the answer is, 5 is counting the number of times that you wrote that you have to add 2 to itself. If you count this, you get 1, 2, 3, 4, 5. So 2 times 5 means take the number 2 and add it to itself 5 times.
And if you do it the opposite way, then it would say 2 groups of 5, which is also 10.
That's right. So you're saying if I write 5 times 2, then that's saying take the number 5 and add it to itself 2 times. And that equals 10.
And that's what we're doing
And this
there.
equals 10. Exactly. So actually, what this picture shows, this picture is kind of a proof that 2 times 5 is the same as 5 times 2. Right? Which maybe is kind of surprising because the 2 here was corresponding to the number and the 5 was corresponding to how many times we have to add it. So it seemed like they were really different. But it turns out that 2 times 5 and 5 times 2 are the same. And that's going to be something that's always true. Whenever you have 2 numbers and you multiply them together, if you put them in the opposite order, it's the same. So before we get to that, I think we need more examples. So let's look at a couple of examples just to get a feel for what multiplication means. Let's try this one. 3 times 4. Now I don't want you to answer the final answer. I wanna figure out, what does this mean? It means take the number 3. So you start with the number 3 and you add it to itself this many times, 4 times. So I have to write 3 plus 3 plus 3. How many more times?
1.
One more time. Plus 3. That's what this means. It's kind of like a short form. If this is too long to write and you get tired, instead you can write this. 3 times 4. That means 3 plus 3 plus 3 plus 3. And what is 3 plus 3 plus 3 plus 3? You want to answer?
Well, if you break, since there's 4 of them, you can break them into 2 equal groups.
That's right.
2 3s is 6, so 6 plus 6 is 12. That's how I did it in my brain.
Yeah, that's a good way of doing it. These 2 3s make 6, and these 2 3s make 6. And 6 plus 6 is 12. So we figured out 3 times 4 is 12. Right?
Yeah.
And now let's do it the other way around to see how it's different and also how it's the same. The other way around would be 4 times 3. So now the number that comes first is 4, so it says take 4 and add it to itself 3 times. So how many times do I have to write this down? 4 plus 4. Any more times?
2.
So I've already written down 2 times, but I'm supposed to take the number 4 and add it to itself 3 times. So I've got 4 plus 4, and how many more times do I have to add it?
1.
Yeah, 1. Because now it's 1, 2, 3 times. Right?
What is it equal?
Good question. What is 4 plus 4 plus 4 equal? Why don't you tell me the first part? What's 4 plus 4? I think you can do that.
Eight.
8. 4 plus 4 is 8. So now to figure out 4 plus 4 plus 4, we can just do 8 plus 4, right?
And what I did is 8 plus 2 is already 10, plus the 2 more that's left over is plus the 10 is 12.
Alright, I'm going to draw a picture of what you did because there's lots of different ways of adding things, and this is a good way. You split the 4 into 2 and 2, because 4 equals 2 plus 2. And the reason you did that is because then 8 and 2 is 10. That's just something that you recognize. And 10 plus 2 is 12, because it's easy to add numbers to 10. So yeah, nice. So what we saw is we got our answer of 12, just like our answer up here. So it's another example of how if you switch the order of the 2 numbers, it gives you the same answer. Right? Do you want to do one more example?
Yeah.
Okay. Let's see. What should we do? How about 5 times 3? So this says take the number 5 and add it to itself 3 times. 1, 2, 3. Got it. Right?
But what does that equal? Because 5, we know. So we'll start with 10. But then, what's 5 more plus 10?
What happens if you have 10 and you want to add 5 to it? You know?
15.
15, yeah. So if you have 10 and you add 5 more to it, it gives you 15, a 1 and a 5.
I did that by counting my 5, 10, 15.
Yep, that's a way of doing that. And then if we look at the other way around, we have 3 times 5 equals 3 plus 3. How many times do I have to write down 3? How many times do I have to add 3 to itself? 5 times. Okay, so I'm not done yet, right?
No.
Okay, you tell me when I'm done. Plus 3, plus 3, plus 3.
That's done.
That's done. Okay, good, because I got 1, 2, 3, 4, 5.
Because I counted, because I put how many you got, and you only got 2, so you added another, and then another, and then another, and then when I got to 5, I said that's it, because that is it.
Yeah, that's a great description of what happened. Good job. So now we've written down the right thing, and it's super long, which is why we might like to write this down, because it's shorter, right? We've written down this thing, and it's long. Let's add it up and see what it is, right? So how would we add this up?
I would swap it.
Swap what?
I would swap it the other way around because that's easier for my brain.
You mean do the top one? Well, we already did that one, so let's do this one. Let's do the sort of the hard way and make sure that it actually works. And it's still the same number. Because this is 5 times 3, and this is 3 times 5, and they're just the same multiplication but in reverse order. So it should be 15 if what I've been saying is right. Okay? So, well, let's do it. 3 plus 3, that's 6. Right? And 3 plus 3, that's 6. So we already actually did this part in the last question. 6 plus 6 is 12. So all we have to do is add 3 more.
And since and 5 is made of, it's 15.
Good job, Athena.
And 5 is made of 3 and 2. So the 2 we already have was 12. Plus 3 more will equal 15. That's another way
That is another way of doing it. You could split this into 10 and 2, and then do the 2 and the 3 together and make 5 and 10. So there's lots of different ways of doing it. Athena just counted starting from 12, 13, 14, 15, and that works too. So we got 15 in both cases. And actually, since we started with a picture, let me draw the picture, right? 3 times 5, if I was going to draw that, I would draw it like this. Because I have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I have 3 squares high and 5 squares across. So it's the same as saying 3 plus 3. Yeah, plus 3, plus 3, plus 3. It's the same as this thing that's still written down right here. Right? But another way to do it that looks more like 5 times 3 is I could write it like this. And I could do now what do I have is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's 5 high and 3 wide. Oops, I didn't leave myself enough space. So we've got 5 plus 5 plus 5. And that's what we did originally. 5 plus 5 plus 5.
Yeah.
And the thing that I want to really show you is that this rectangle and this rectangle, they're the same rectangle. Because if I take this one, watch carefully, if I take this and I turn it, it becomes this one. This rectangle is just this rectangle turned to stand on its small side. Right? 3 and 5, and this is 3 and 5. So there must be the same rectangle.
Because if you go from the bottom and count by the bottom up, that's still the same as that because you're counting that way on that one. And if you count up, then that's the same as that.
Yeah, that's exactly right. I'm glad you said that. So what you're saying, if I understood you, is you're saying instead of doing 5 plus 5 plus 5, I could also do 3 plus 3 plus 3 plus 3 plus 3.
And that's the same as the other one.
Exactly.
Because the other one is just turned to to its side on the bottom.
Exactly. So that shows us that both of these rectangles have 15 squares in them, and that shows us that 5 times 3 is the same as 3 times 5, because they're both ways of counting the number of squares in these two rectangles, which are really the same rectangle.
Yeah.
Good?
Good.
All right. I think that's a wrap.